A couple weeks ago, a lovely viewer of the channel asked for some textbook recommendations as they're just about to start doing astrophysics, so today that's exactly what I'm going to be talking about. Now, I will try my very best to not deviate from the topic at hand because we do have quite a lot of books to go through, but I will be trying to give some very detailed reviews on these books, most of which I have actually read. In fact, for quite a lot of them I've read them cover to cover and have gone through them quite extensively. There are a couple which I haven't necessarily gone through, but I have asked for the recommendations from people who are experts in the field, who I work with, or from other students who have gone through that topic and have recommended them. I should make an important note that you really do not need to be reading textbooks before you start your degree. This is just something if you are really interested in the topic and want to sort of get a good footing of it beforehand. The whole point of the degree is that you have loads of resources and contact time with experts to help build up your knowledge, so you don't actually need to be an expert in the first place, so don't feel pressured to do so. All I'd say is that if you've done physics at high school or A-level or the International Baccalaureate, and you feel confident with the syllabus and you know it really well, then that's kind of all you need to go into a degree, but this is more just supplementary stuff. So before we start, let's talk about what I look for in a good textbook. Good textbook might not necessarily cover all of these subjects, but hopefully they should hit most of them, and depending on what level they're aimed at, they don't necessarily have to meet all of these criteria. The first thing I would say is that they should ideally contain problems and some easy to access solutions, and in particular I would recommend that these problems are quite varied. The point of them is not necessarily that you are able to do them right off the bat. They are like a step in the learning process and reinforcement process, so don't feel pressured to be able to get them all right on the first round. That's not really the point of most of them anyways. They're more just there to tell you what your level of understanding is at and where you need to improve. The second thing is that they should have a really good logical flow, which can be difficult to judge if you're very new to the subject and haven't looked at it before, but that is kind of why I'm here, who has read the textbook and has knowledge of some of these all of these subjects, to be able to tell you if there is a good flow or not. Ideally, for example, if you were to look at a very basic physics textbook, I would suggest, prefer that it would start off with something simpler, like Newton's laws of motion, and then go into stuff like, fluid dynamics, thermodynamics, like rocketry and that stuff, as opposed to it being the opposite way round. So it should start to build up the level of complexity as you progress through the textbook. I am trying to balance this camera and my laptop on basically my foot and my bed, so I'm really sorry if it's wobbling, but I'm trying really hard to stay still. Now, I haven't read every textbook in the world, so when I was much younger and trying to look for really good ones, I would definitely, I would take advantage of a lot of the reviews online. These might not necessarily be on the bookshop's website, which can be quite biased at times, or Amazon reviews. I wouldn't go there. I generally tend to look at things like forums, quite old ones as well, Reddit and even Facebook, dare I say. Sometimes people do give detailed reviews there, and detail is the key here. You really want to look for, reviews that give a good insight onto their experience with it, whether they found the chapters were at the appropriate level, how complex things progressed, that kind of stuff, how they found the problem questions. Another really important thing that you might find quite useful as well, as I did, was if this person were able to found it was more beneficial as a supplementary thing alongside lectures, or if they could really get a good hold of the subject as from the textbook as a standalone thing as well, which can be quite useful to consider. Hopefully this video will also serve as a very detailed review into these textbooks and can help inform you as well. Finally, one thing that's not necessarily important, but I find it particularly important to mention, is that in general physics textbooks can be quite old and still hold up pretty well. Ideally something that's post World War II, mainly because physics had quite a big boom. We're talking about Maxwell's equations, quantum mechanics, all the really big stuff that kind of just discovered huge areas of physics. So you'd ideally want to stick 1950s onwards at least, but in general, when we're talking about maths, it kind of isn't time dependent. If the maths is solid, it's fine. I would say with the older textbooks on physics, just in general, that the physics might be there, but you might be missing quite a lot of big areas. So for example, a mechanics textbook from back then would not talk about like rocketry the way that a modern one might do. So, you have to be careful with that. You might just not be getting the full like sort of scope of the topic at hand, which is completely normal. When it comes to astrophysics though, and space themed topics, I would actually do the opposite. I would go with the most recent edition as possible with things, try and keep things as updated and up to date as possible. That is mainly because when it comes to astrophysics, yes, you are talking about like maths and stuff, that is still getting discovered to this date. And things like parameters and things, like for accretion disks, there's quite a lot of those, or like modeling density profiles, you have, a couple parameters. These are all things that are very recently like discovered, basically. Like it's still a very like active and updating like area of research, so I would always go and look for the most recent thing. So for example, I've got this really old textbook, I think it's about 70 or 80 years old, called Teach Yourself Astronomy by David S. Evans. And in general, things like, for example, the celestial sphere, which we cover right at the start, has been unchanging for the past few centuries. I mean, the zenith is still the zenith. That description hasn't really changed. So things like that would, of course, still be applicable today. But things like, the section on comets, that a lot of data on that has changed. A lot of like theories on that has changed. But one thing that I found really interesting here is that if you go to the planets section here, as if you have the book on hand, but in the planets section, it's got a table of, certain features, properties of the planets. And for example, if we look over here with Jupiter, it only has 9 moons, which we now know today to be very incorrect. So this is one of the reasons why I always advocate for going with the most recent textbook of things, because things get updated so often. I mean, it's just a natural thing. Yeah, the 9 moons was quite interesting. A lot of things about the moons as well, like their diameters here, a lot of them have question marks. So at the time, we didn't know how wide these planets were. And Pluto, which is here somewhere, that also, they didn't know how wide it was. Oh yeah. Oh no, we knew its diameter, but we didn't know its period of rotation, and that's understandable. I think it's quite a long one as well. So yeah, there were just things that we outright did not know that we do know now. So yeah, I think my point stands. So if you're going into astrophysics having not done much physics earlier on, good luck, first of all. But I guess the textbook that I would probably recommend that covers sort of the basics and at least will give you a somewhat semi-good foundation of physics to be able to like go further into astrophysics would be Physics for Scientists and Engineers by Tipler and Mosca. That was the recommended reading for my year group, for my degree, for first year and parts of second year, and it does cover a lot of ground. We start off with things like mechanics, and we cover quite a lot of that as well. Newton's laws, building up onto like fluid dynamics, that kind of thing, pressure, and then going on to things like thermodynamics, statistical physics, thermal physics, that kind of stuff. But it does also cover things like special relativity to a slightly small degree, and very, very small bits of general relativity, but I wouldn't recommend this textbook as a general relativity one. I have one that's at the end of this review that's more specific to general relativity. Wave mechanics, like harmonics, oscillations, like light, all that stuff, the very basics of physics gets covered in this book. And in general, it's really nicely set out. I find, yeah, the text is small, but there's a lot of information there you've got to absorb. There are like really handy, like the way it's set out, there are like some really useful call outs, which I found quite useful. Diagrams are always very like applicable to what's being talked about, and I always find them quite insightful as well. The problem questions are really good. I think they know their audience well. Like it's meant to be like an undergrad level book, so like the progression of complexity is like perfect for an undergrad, I'd say, of somebody who's like really trying to learn physics. It's slightly on the affordable side compared to a lot of textbooks if you want to buy it secondhand or online. It is available online and is fairly easy to access, for digital copies, which is pretty good. If you have a .edu or a .ac account, of course, you should be able to access this for free on something like Cambridge University Press or another website of the like, depending on where it's hosted. If you don't, you really should get in contact with the librarian and get that sorted, because it should be available for you. The solutions are also really easy to access online as well, which is kind of important if you're looking for a textbook that's very much sort of covering the basics. Apparently in the States you don't really have this textbook as much as we do. So I think your equivalent would be, I think it's called Principles of Physics or Fundamentals of Physics by Resnick and Halliday. I haven't read this one personally because we just don't really use this one in the UK, but it basically does exactly the same thing. People have said it's quite dry and dense with information, but that is kind of to be expected with these kinds of textbooks. It is mostly mechanics, but it also focuses on thermodynamics as well. But it is quite comprehensive and expansive within those subjects, so it's a good read as well, I guess. You might think you won't need this kind of stuff for astrophysics, but trust me from my experience, you definitely really do need a good level of physics knowledge to be able to do astrophysics, and in subjects you wouldn't even think would, be compatible with astrophysics or cover the same subjects. You absolutely do. Things that we covered in, third year quantum mechanics, and believe me when I say this, things that we covered in quantum mechanics came up again in galactic dynamics. You cannot escape harmonics and potentials. They're just always there, so you really should make sure to cover your grounds before you go into something more specialised. Because believe me, I am really glad I studied very hard and got good grades in quantum mechanics, because this made galaxies and stuff way easier, surprisingly. In general, you should, of course, cover everything: mechanics, thermo, statistics, not just stats as in thermal physics, but also stats as in actual Bayesian statistics and what's the other one called? Not probabilities, fundamentalist or something like that. But you really do need to really cover a wide expanse of subjects. In particular, electromagnetism is a really key topic that you should be able to understand pretty well, at least with the concepts. Maxwell's equations are, key as well. Gravity in general, I feel like that's quite an obvious one, but also things like angular momentum, and being able to mathematically, talk about angular momentum. That's a really useful one as well. If you're more into the observational side, then optics and materials is actually really key to observational astrophysics. I mean, light behaves very differently depending on what sort of band that you're in. So there's a lot of overlap between material science, like lasers and light, and then how you are able to observe the universe, for example. These are all they're all really heavily tied in together, so you should try and get a really good baseline knowledge of that. Right, I think we should actually go on to the actual astrophysics textbooks that I recommend. I think the first one is probably been recommended thousands of times already, but once again, in my experience, I have to recommend this one as well, and that's Carolyn Osley's Introduction to Modern Astrophysics. I would, in general, say it's one of the best all-around astrophysics textbooks. It covers so much stuff. It has 30 chapters, if I remember correctly, and we go into things for example, we start off with things like Kepler's laws, if I remember correctly, and what light is, which is quite an important part of astrophysics and observational astrophysics. We go into stellar astrophysics, the interstellar medium, that kind of stuff, interiors of stars, atmospheres, remnants of stars, galaxies, cosmology. So we go from small scale to large scale, all within this textbook. It's really, really comprehensive, in my opinion. There is also a bit of planetary stuff as well, because you can't really escape that as well. But it does focus more on sort of the larger astrophysics stuff. I think if you don't know where to start, but you just want to sort of learn astrophysics, this is probably the best textbook that you can start off with. It's designed for people who are doing their undergraduate degree, hence it is usually the required reading for most courses, I think, in the world. You don't need a first-class degree in physics to understand it. It is meant to be there to help you learn things, and like it is meant to help you go from being like a beginner to somebody who's way more advanced in their knowledge in astrophysics. So like it's not extremely complex right off the bat. It's like they do sort of guide you through the subject. One thing that I particularly like with this one and with many of the textbooks that I recommend is that they also go into some further reading at the end of each chapter, and it's like split up by the chapter as well, so it doesn't sort of overwhelm you like in some books. And they do also contain quite a fair few problem questions, which I think it covers a lot of ground personally, and the solutions are really easy to find online, which is really useful for somebody who's learning. In general, diagrams are also quite prevalent throughout the textbook. I think every other page had a really useful diagram that was very applicable to what was actually being talked about in the book and in the chapter. I used this book really extensively during my revision sessions, and it was a really good help in solidifying and like consolidating my knowledge. And I think it was really fundamental to me to getting like higher grades. I quite like the clarity of the writing within this book. It was really like communicative and like fairly easy to understand. I say fairly easy, that's like relative to a fiction book. Of course, it's a lot more difficult to understand, to communicate through this, but like, yeah, it was pretty clear in general. Be prepared for a lot of maths and derivations, which is expected in a textbook. But overall, I'd say this is a really good first read. Since this one covers a lot of ground, I think the next textbooks, I decided to split them up into slightly more specialised areas. So we're going to start off with cosmology, because I have two pretty good textbooks to recommend for that one, and then we'll move on to other topics. So for cosmology, I think a really good next step would be Intro to Modern Cosmology by Andrew Liddell. A lot of books will start off with like Intro to Modern and then the subject, which I thought was really interesting. But yeah, back to the topic at hand. This one I loved a lot, and I have read it cover to cover at least once now, and like, yeah, it's absolutely fantastic. And I have like quite extensive notes on the textbook as well. And I did get one of the highest marks in cosmology for this course, so I can definitely say it was really helpful. I would say, yeah, if you've gone through Carol and Osley's cosmology chapters, and you want the transition into just going into cosmology as smooth as possible, that would be a good start, and then going on to this textbook. But you don't necessarily have to do that per se. You should have a pretty good like understanding of like physics equations in general, like explaining concepts through maths. That's quite an important thing in cosmology in general, and this book is quite good at easing you into that as well. I'd say the problem questions were fairly on the easier side, but you do have to bear in mind that I had already done a lot of cosmology before. I did a course during my like high school years, so GCSEs, and then I'd also done cosmology beforehand in like other courses, and I've read textbooks before on this. I think it used to be quite a big special interest of mine. It probably was, so bear that in mind when I say these problem questions were easy. I'd say for a normal person they'd probably be like a fairly good challenge, but yeah, answers are also included at the back of the book as well, so that makes them even more easier to access. This textbook is quite short. It is like, you know, it doesn't go into like extreme depth with these subjects, but you do cover a lot of the basics of cosmology to a pretty good degree. Yeah, I would say this textbook would be great as sort of like a supplementary thing alongside like a cosmology course, and of course the reading that's required of that, if it isn't Andrew Liddell already. Yeah, it's really good for that, or if you want to like dip your toes into cosmology. I'd say the next natural stage for a cosmology enthusiast or student is probably Peter Cole's and Francesco Lucin's, I think it's just called Cosmology. It's like origin and evolution of structure, whatnot. It's the most intensive cosmology textbook I have ever been able to get my hands on. It's quite dense in terms of a read, but it does go into, I think, almost everything you could possibly think of with regards to cosmology. This book did humble me quite a lot, actually. You know that graph where you have like your like perceived expertise in the subject and like as your actual expertise as you like progress into the subject, and it like goes up really high and then it like dips really low as you like gain more and more expertise, and then you slowly climb back up. Like I was like somewhere just after the peak, and like after I read this textbook I just like plummeted right to the ground because there was so much in this textbook that just like really humbled me and my perceived expertise. I mean, there is a section in this textbook called Nucleocosmochronology. Yeah, we're covering those kinds of things here. Apart from weirdly named areas in physics side, we cover a lot of cosmological models, especially at the start, which I think is really useful. Friedmann equations, you know, the fundamentals and the metrics. The Big Bang, we talk about a lot of like areas relating to the Big Bang as well as you go through the textbook, like the lepton era recombination, like also inflation. There are multiple inflation models that this book covers, distance ladder and calibrations, expansion, in general genes theory, like gravitational instability and like galaxy formation, things like the Sunyaev-Zeldovich effect, and like observing at like really high redshifts and any biases that we come across with that. There is a lot of information within this textbook. The thing about Cole's and Lucine's cosmology is that it's quite a dense read. It's very heavy on wording and not necessarily always clear, which is to be expected. We're covering quite complex topics here. It's not going to be an easy read at all, so don't go into that expecting it. But like it's also very maths heavy, and I think if you're able to like pick out really key concepts from maths, like for example, like one really simple one that isn't really cosmology, like the divergence of the magnetic field equals 0, so div B equals 0. If you can understand what that actually means and the consequences of that, like, but in terms of cosmology and like cosmological concepts, if you can understand like what maths is trying to tell you through the equations, through derivations, through like fundamentals of that basically, then this would be a pretty good next step for you. But if you're not at that stage yet, I would steer away from this book at the moment and like come back to it when you have a little bit of a better understanding. They also have some pretty good concept questions, but they are very challenging, which is to be expected when you're covering challenging topics, and I didn't have much success with them initially, and I had to get quite a lot of help with my lecturers on them as well. So yeah, I would say it's pretty good if you've got the support system of like cosmologists at hand. So if you're doing a degree that involves cosmology, but apart from that, if you're on your own and you're not really like, you haven't got quite a solid footing on like cosmology yet, maybe don't go for this one just yet. Right, let's talk about something that's not as expansive as cosmology, no pun intended, and go on to something that's a little bit more smaller, like stellar astrophysics and like protoplanetary disks. I think when it comes to stellar astrophysics, I don't have many good textbook recommendations. Not saying that they're all bad, but that I haven't read that many and I wasn't recommended that many in terms of reading. In general, when it came to learning about stellar astrophysics and like the recommendations that my lecturers would give, it would just be actual papers and reviews on the ArXiv and like ADS. Mainly because I think when it comes to stellar astrophysics in general, with this subject in particular, a lot of what we're sort of researching and like what we know about stellar astrophysics is still being like updated. It's like very much an active area of research. So the best way to learn it is to like go with the research itself. In general, one thing that I found really useful to go through were some fairly good comprehensive reviews on ArXiv. That's ArXiv, which you can like get PDFs of online for free, and those were pretty helpful in terms of learning about stellar astrophysics. Yeah, Carroll and Osley have quite a lot of good reading and further reading on, you know, general stellar astrophysics stuff. So we're talking about the cores of stars, stellar atmospheres, the ionization zone around them. I am not able to speak English today. I don't know how to pronounce them, and it's too early in the morning to pronounce it, but yeah, that kind of stuff. I don't really remember or recall them going into much about like protoplanetary disks and like baby stars, basically, like, and like how they influence planet formation and that kind of stuff. So in terms of textbooks for that, I haven't read much on them, but I do have recommendations from some lecturers and some students as well. and the main one that came up was Protostars and Planets. I think the authors changed depending on like what edition it is, so there are quite an expansive like list of people who have contributed to this, but it is like the most expansive textbook on planetary formation and protoplanetary disks. It gets updated a lot, like I just said. I think it's on its 7th edition now, but it's also very expensive to purchase a copy of this, so it's not the most accessible read, unfortunately, so I can't give you much like detail as to like what it goes through. Philip Armitage also does have a textbook. I think it's like called From Protoplanetary Disks to Planet Formation, something like that. But once again, it's also a bit expensive and hard to get a hold of. But if you go onto the ArXiv, you can find reviews. Well, not reviews as in like book reviews, but like a review, like a literature review, that is from this textbook in particular. Like you can basically find bits of the textbook that Philip has posted online to the ArXiv that you can read for free, which is why I mention it. So that will probably be the best next step for you in terms of protoplanetary disks and stuff. You do need a very good baseline knowledge of like accretion stuff, which we will get into in a second if you want to really get a good hold of like what's being talked about there. Yeah, my partner does recommend Philip Armitage's work in general. He is quite fond of his writing style, so I naturally would just trust his opinion and recommend him to you as well. In terms of if you want to go more onto just the disk parts of protoplanetary disks, but also accretion disks as well, I really recommend Frank King and Rain's Accretion Power in Astrophysics. I actually knew Andrew King very, very like vaguely. He is the second Andrew in astrophysics that you will hear about. But yeah, he was working at my university until like the year I started, basically, which was during COVID, so I didn't actually get to meet many people in person, but I did like very like distantly know him. This textbook was actually really, really monumental in my accretion and supermassive black holes coursework. It was such a good help, and like it complemented the lectures really well, and I think on its own it also was quite useful as well. In terms of like the flow of it, I think it works really well. In particular, this is quite a really good like standout book. It has had many additions as well, so like clearly like they know what they're doing. Like they've had a lot of revisions and like really good sort of updates to the book. It's like it's really polished, basically, is what I'm trying to say. It starts off with like quite simple like the core principles of accretion and accretion disks, so like how it gets its energy, like the energy release, like what is actually an accretion disk. But then you do go into things that are a little bit more complex later on, like plasma physics, accretion flows, disk dynamics, that kind of stuff. And then you go on to things that are slightly more like tailored to situations like active galactic nuclei, accretion disks like in AGN and whatnot, and like around supermassive black holes in particular. At the end, it does also cover thick disks, so quite a lot of our understanding of disks comes from like work on 2D disks, but they do also expand upon 3D disks as well at the end, which is quite good. Now, when I was first reading this book, I didn't see any problem questions at the start, but that's because they were all at the end of the book. So there was like a big gap where I just didn't like do any of the problem questions, and I didn't really think they had any. But yes, they do indeed have some. They start off really easy, which is great, but then they get considerably harder as you go on, which is exactly as I would hope in a textbook. But overall, they were a really good level of challenge that really like complemented what was being written and like derived in the book. So I think the next step in my textbook recommendation would be one for active galaxies. I feel like we have just kind of gone full circle, where we've basically done a game of word telephone, going with stellar astrophysics, protoplanetary disks, and then active galaxies and stuff, which is quite funny. We're basically back at cosmology. But one textbook that I would half recommend is Bradley M. Peterson's Intro to Active Galaxies. I've got a copy of it right here. I managed to get it for £3 on eBay, which was pretty good. I wouldn't recommend getting it brand new. Don't support the author. I don't support him at all, but his writing is unfortunately like fairly good. it is very much an intro to active galaxies, but it's not for somebody who hasn't done physics or astrophysics before. You would need quite a lot of prior knowledge to be able to understand it right off the bat, which is to be expected. This is a very sort of tailored textbook to like an object in space, so there's quite a lot of background physics that you do need to be able to understand this. Namely, a lot of like spectral stuff. It does go into that quite a lot, so I would brush up on your understanding of spectra and spectroscopy as well. But also there's quite a lot of models in terms of like accretion and accretion disks and whatnot, so I would recommend Franking and Rain's accretion power before going on to something like this. I personally think it's really great with its information. It goes through quite a broad range of topics to a pretty good depth as well. And I feel like most of the maths is really well guided most of the time. One thing I'd say is that when you start off and like you've not like looked at AGM before or haven't really covered the topic, the flow kind of doesn't really make much sense. It can sort of feel like you're jumping from things to things and nothing's really connecting. But trust me, once you start to get the hang of like active galaxies and like then the active galactic nucleus and topics surrounding that, it does make a lot more sense when you've like brushed up on that and like you have a bit better knowledge of it. It's just it doesn't necessarily feel like that when you first start off reading it. At least that's how I felt initially. Like when I was doing my third year, so my bachelor's dissertation, which was on finding masses for AGN, that was what my research was on. Like, I didn't really know how to even, like, word my intro, my theory. Like, because, like, it just feels so, like, disjointed at times. And I did kind of get that from the book as well. But once you start to, like, find your footing with AGN, like, it makes a lot more sense. So for something like AGN, I would recommend starting off with Carroll and Ostley, which I don't recall them going into AGN in much detail. But you will at least get some baseline knowledge of, like, some of the fundamental concepts. I'd then go on to Franking Rain's accretion power in astrophysics, because they cover AGN quite extensively as well in there, but not necessarily on its own thing, in its own right. And then going on to something like this, or a suitable alternative. There are no problem questions in this textbook. It isn't really meant to be like an intro to physics, because it's a lot more, at a higher level, basically. So it's not really the kind of textbook that's more for learning, per se, like the way Carroll and Ostley is, so you wouldn't expect problem questions with this one. But it does have a really extensive bibliography at the end, which I found particularly helpful when it came to like doing my own literature reviews on it. Also, yeah, get it secondhand, don't buy it new at all. So I guess the next logical flow of my review of books, my recommendation would be to move away from the nucleus of an active galaxy and to move more into galaxies in general. And that would be, my next recommendation would be Galactic Dynamics by Binney and Tremaine. As a disclaimer, I am currently reading this, so I haven't covered every single aspect of the textbook yet, but it's very much fresh in my mind, so at least there is that. I would say it is quite a dense book at times, but it is a pretty good book in general. It is one of the rare cases I see where a textbook is cited in like active like research and papers, even still to this day. So if my review doesn't convince you, I guess that fact would hopefully convince you that it is quite a favoured textbook within the galactic dynamics sort of community. In general, I think it does start off with a bit of cosmology. I didn't really read chapter 1 because I didn't really need to, having read the other textbooks. But like in chapter 2, 3 and whatnot, we start going into we start off with more mathsy things like potentials and whatnot, but we do talk later on about things like spirals, bending waves, density waves, like warps in galaxies as well. Yeah, chapter 6, I've like read that one multiple times now because it's so like related to my research. But yeah, it's pretty good. It covers like a lot of galactic dynamics, as you would hope it would. It's like 600 pages at least, I think, so it's quite a big book. My recommendation would be to read it in order, and things will make a lot of sense and the logical flow is really good. I think Binney's writing really lends itself to good communication. Like, I don't know how to explain it with some authors, but it's like they're talking to you about the subjects as opposed to like just stating things. hard to explain, but I do quite like Binny's like way of communicating topics. There are times where it does get a little bit convoluted with sort of like the terminology and like the wording, but I think it couldn't, in some of these cases it really can't be helped. At some points, you know, you're just talking about complex things. It's not possible to word it any simpler than you have, and like that's fair. In general, I think the diagrams in this textbook are some of the most helpful. In general, they're really, really good at sort of helping you, like supplementing what's being written down. Like for example, in chapter 2.3, where I think they cover potentials of flattened systems and whatnot, there's like a lot of very like if you just look at the maths of some of these potentials, like the Miyamoto-Nagai potential model, it looks absolutely insane, but like the diagrams really help sort of explain like what the potential looks like, and so I found those particularly helpful. But yeah, in general, it's like a really nicely like set out textbook. Binny also likes cracking like snarky jokes every now and then, which I found pretty funny. I've like started to like copy paste them, like write them into like a section of my Notion notebook that I've been using to like look at all, like summarize all of my papers and like research. But yeah, it's quite funny at times. It does make me lose concentration sometimes, but in general they're very welcome, I'd say. Yeah, the notebook also has like a lot of snarky things from other like papers as well. In general, I find that Galactic Dynamics has like quite a healthy amount of like humor and comedy at times. A lot healthier than Planetary, let's just say that. The main thing I'd caution with Binny's textbook is that he does this, I've noticed this a lot more in this textbook than other textbooks, but he does reference back to previous chapters, but also forward to like upcoming chapters as well. A little bit more than I would usually expect with a textbook. Don't actually go ahead and read that, because you will be jumping back and forth like a lot, and you will just lose your pace and get quite confused in general, especially if this is like your first time like reading the book, or like your first steps into Galactic Dynamics like it was with me. Yeah, don't do that. Please don't. Granted, I have seen much worse in other like actual reviews, like by researchers like reviewing like the state of Galactic Dynamics in general. One of them was so bad, they were like they weren't even referencing backwards, which I can understand, especially with like this textbook, like, which is absolutely fine, but like they were referencing forward like at least 3 times per subsection, which is insanely like bad. Like just objectively, like you need to restructure your review clearly. And at the end of the day, I got to like page like 10 or 11 and I just gave up, because it was just impossible to read. Like how are you covering this like 3 different times in 3 different like areas, and like you're expecting me to jump back and forth between all the chapters? I'm not doing it. But yeah, with Binny's Wonder, he's mostly referencing back to just chapters 2 and 3, which is kind of understandable. Those are like the main ones. So my recommendation is to just, if you want to like go at it in your own order, at least cover chapters 2 and 3 first, and then go forth and play around with like when you want to like read things. That will alleviate most of it, which is fine. In general, yeah, if you do that, you will probably find the flow of the rest of the book to be a lot easier to, you know, go through. I'm really sorry to Tremaine. It's Binny and Tremaine's book, but like, I always just say Binny. I'm so sorry. But at the end of the book, there is a list of references. There aren't that many references like in the text, and it's not really split up that much. So it's a bit difficult to go through some certain things and like do some further reading. But I think at the end of the day, this kind of textbook isn't meant for like somebody who's just started undergrad and would need a lot more support with that kind of stuff, like the way Carolyn Ottley's set out. It is meant for somebody who does know what they're doing, sort of. So there is that sort of expectation at hand, but there are some useful references at the end. I should note that the edition that I have, at least, and I think the most up-to-date edition, is from 2008, and since then there have been a huge amount of papers on galactic dynamics, specifically spirals, mainly because, you know, we launched Gaia in 2013 and it's only just stopped working, so we've had all of this data, all of this information and like knowledge and papers that just aren't really like incorporated into the book. but you know, the maths and the theories still mostly stand. So we're on to my final textbook recommendation, and we're going to go a little bit more large scale and more towards the maths with general relativity. Carroll and Osley, I think they do cover it a little bit, but in general with physics stuff, they tend to talk more about special relativity and then not really go into general relativity that much, because it goes from 0 to 100 very quickly, let's just say that. But the one textbook that I would really recommend is Bernard Schutz's General Relativity. I don't really know how I came across this textbook initially, because it wasn't on my suggested reading. There was a different textbook by somebody else. But for some, I don't know how my brain did this. It didn't register the book that was being like on the website, on Blackboard, that was in the suggested reading list. And I was like, oh yeah, it's Bernard Schutz's General Relativity, that's the recommended reading. Having never come across this book, and I've only really come across like Bernard Schutz in terms of like his stuff on gravitational waves, but I guess the heavens aligned and there was a textbook available and it was a really good one, so I'm glad I picked that one. I read this in the summer before my general relativity course started, and I am so glad that I did. It familiarized me with like really important concepts like, I guess like tensors, first of all, notation, which is very different compared to standard physics, like Christoffel symbols, everything. I was so like, it was such a good introductory read that when I actually went into like doing the lectures and like attending lectures and the workshops, things made sense so much faster. And like, if I hadn't gone through that book and had got a good understanding of like general relativity beforehand, I would have been so stuck with everything. So I'm really glad I came across this textbook. Like I just mentioned previously, it does cover notation, first of all, which is different to standard physics at times. Tensors, Christoffel symbols, curved space-time in general. I shouldn't say the word general for general relativity, but yeah. So it covers quite a good broad ground. It's very much more on the math side, which I think is really beneficial in this case. And yeah, it generally made my course way easier. In general, the maths was pretty well described at each step, so I was able to follow through very, very well. As a lot more compared to like, I don't know, Coles's cosmology, for example. But yeah, I found that to be really beneficial in this case. The flow was pretty good. I did have an online copy that I was accessing at the time via, I think it was Cambridge University Press's website, and the mathematical typesetting is awful on the digital copy. It's like truly annoying and really like, yeah, it's just terrible to read. But I'm guessing if you have like a physical copy of the book, or if you can access it some other way, you'll probably have a much better time with that. Yeah, it just looked really grainy, and like really expanded, which was very weird. But yeah, that won't happen if you've got a physical copy of the book, of course. There is a bibliography at the end of each section, which is quite nice. Yeah, it's definitely geared towards somebody who's learning and getting introduced to general relativity. It kind of says so at the back of the book anyways. But yeah, I think it is a really good introductory read. The exercises, some of them lead on pretty well from what's being covered in the chapter, and they do sort of like stretch you a little bit at the end. Right, so that kind of covers every textbook that I recommend. I do have, of course, a lot of more sort of general physics textbooks that I found really useful, but given that this is more geared towards astrophysics, I haven't really talked about them at all here. I think we should end off this video by me recommending where to get textbooks as well, because that's also important. Also, a further note is that if you're confident with what you've learned in a textbook and like you feel pretty like good with the subject, the next step naturally is to just read papers that are being published on the subject. Sure, a lot of the writing can sometimes be, quite a big step up from a textbook, which, some of them are geared more towards undergrads who won't have that sort of like reading knowledge, like reading skills. But they are really good to get like a good handle of like research that's going on right now. And they do have good theory sections, some of them, which, can like help teach you some more concepts as well, which, read papers, definitely read papers, always read papers, they're all great. Now, where to actually get books? I think the first thing we should say is that I would first recommend trying to get online copies and try to save your money. Basically, don't worry or care about the authors. They don't actually earn that much through textbooks, at least in Europe and the UK. I guess not so much with the US. You guys are insane with like your textbook recommendations and prices. Yeah, but anyways, for example, one of my lecturers has his own textbook on statistical physics, and he gets like the equivalent of like $6 a year. In that sense, I would say try and look for online PDFs of a textbook, especially, if you're just looking at like just having a general read and want to get a feel for the textbook as opposed to like fully going into it. That I would recommend trying to do that first. Have a look on the ArXiv as well, or Harvard ADS as well. That's quite useful in terms of looking not just for papers, but there are really good reviews which, sort of are books as well in their own right. For example, Philip Armitage's reviews, they're all on the ArXiv. They're really good. They're based on the books that he's published, so go read those, and they're free, of course. If not, secondhand would then be your next best option. I usually start off by looking at eBay, but another website that I would recommend is World of Books. They do things extremely cheaply. They sell secondhand books for really good prices. I think every single textbook that I have bought from them, I have bought for less than £10, and then I think the vast majority of them have been less than £5. I think only one of them was like actually above £5, but below £10. Everything else was really cheap and, pretty good. Shipping is free for most orders above like a really low threshold as well, so that's really great. And I think they do ship to like the majority of countries and territories in the world, so they're a really great accessible option, I'd say. So I hope that this was a very informative and useful video for you and has at least informed a little bit of your textbook selection process that you might be going through right now. I do highly recommend like all of these books, some more so than others, of course. But yeah, these are pretty good foundational reads that I have personally found, or my partner and the lecturers that I talk with have personally found to be really informative and very useful. I hope this has helped you in some way or another, and in the meantime, I will go grab a cup of tea and see you very soon.